It's just a condenser. Help's overrated, right? This video is brought to you by Sporlan. Quality, integrity, and tradition. We have a service call on a package unit that is not working properly today. This is their bar AC. I'm just walking up right now. Nothing jumping out at me. I can hear the indoor blower motor running, so we're gonna have to open up the controls section and dive into it. I'm not gonna power down the unit because I wanna open it up and diagnose before I reset anything. Because oftentimes on many of these units, it doesn't matter what brand, oftentimes a power down resets safeties. So we don't wanna have to worry about that. Also, I got my umbrella here just to protect me because we're having a little heat wave, so nice little sunshade there. So we're gonna open this guy up right now. These older Reliatel units aren't too bad. Can't say that they're my favorite, but it's not so much that I don't know how to work on them or they're unreliable. It's just that I'm comfortable working on something else. But I'm the most comfortable working on a Linux L series package unit. Those are what I'm most comfortable with. So open this up. Nothing really scaring me, so we're gonna start by checking control voltage and going from there. All right, we're gonna check three-phase power. Line 1 to line 2, we got 202. Line 1 to line 3, we got 202. Line 2 to line 3, we got 202. So we have three-phase power coming into this guy, which is good. The next thing we're gonna do is check control voltage at the thermostat terminal board. This one has a conventional thermostat. So from R to C, I got 26 volts. From Y1 to C, I have 26 volts. From W1 to C, I got nothing. From G to C, I've got 26 volts. From Y2 to C, I have nothing. So I don't have, oh, I'm sorry, that's W2. Y2 to C, so I have a call for first stage cooling and second stage cooling. As I'm testing control voltage, I noticed that I've got an error light right here, and I didn't catch that when I first came on. It's flashing two flashes. Two flashes. And if you come over here to this guy right here, it tells you that RTRM, basically 2 quarter-second flashes. It's telling you that diagnostics exist. Kind of further looking into the unit again before I reset anything, I'm just going to go ahead and spin the condenser fan motors and stuff. But I came over here to the economizer section because economizers are constantly a failure. And I noticed that economizer's not even hooked up. The board is just sitting here, not even hooked up to anything. So I don't know that that's going to be the problem or not. So again, I'm just evaluating. I'm going to do just spin the condenser fan motors to see if anything will spin, and then after that we're going to have to reset it and power it up and just see what happens. The indoor blower motor is running, and without shutting it off, the belt looks pretty tight. Moving good air. Filters don't look bad at all. So we're looking good so far. Like I said, I'm just going to test those condenser fan motors, make sure they spin, and then we'll reset it and see what happens. Here's a little tech tip. When you are looking at these schematics, especially on these units, you do not, if you can, want to wipe these off with a towel. Don't, okay? Take your brush, your coil cleaning brush, and just brush them lightly. Wiping them with the towel, oftentimes when the schematics get old, will rub the paint, the print right off. So these brushes really do a good job of just cleaning them up because it's a real light, and you don't got to go crazy. Don't use a wire brush or anything, but just give them a light brush because you'll wipe that stuff right off. And I'll do this. Let's see if I can make it happen. Well, this one's not bad yet, but sometimes if you take a towel, it'll wipe the print right off. So yeah, but use the brush. It'll really help you. All right, we are powered back on. We're running on first stage right now. Second stage is not running yet. Shut that panel. Let's check to see if both condenser fan motors are running. This condenser fan motor is not running in the right direction. Look at my head pressure climbing like crazy because that condenser fan motor is going in the wrong direction. I grabbed my meter out to test the condenser fan motor, and we shut off on high pressure before I could get in there to test it. So we're gonna have to reset this again, but we probably got something going on. Well, we know we have something going on because one of those condenser fan motors was spinning in the wrong direction. Whether or not it was actually spinning or just being sucked in the wrong direction, it's hard to say. But I'm gonna dive into it a little bit more. All right, I powered the unit down to reset it again, but since I had it powered down, I decided to test the capacitor. This is a 25 microfarad capacitor. And yeah, it's got a good connection, so we have a bad capacitor for sure. So we can try to swap out the capacitor and see if we can get the motor up and running. All right, we fired up, and it's actually blowing now. This one was sucking the air in before, so it's actually blowing the air up. Let's go ahead and jump in here. My condenser fan motor is allowed to run 4.6 amps, and we're running 3.54. So we're gonna let this run for a little bit and just evaluate the system and see how it's operating. We'll wait for the second stage to kick on, and we'll diagnose that too, but it could just be something as simple as a bad capacitor. The capacitor that I put on there is a temporary capacitor. I used a turbo just temporarily to make sure that it works, and I'll go pick up the right one because I don't have a 25 microfarad round. So I'll go pick up the right one here in a few minutes, but I want to make sure there's nothing else wrong with it before I leave. Okay, the first stage does not look bad. Let's go back over here. And mind you, it's still stabilizing out, but I just wanted to make sure that there was nothing crazy going on. So it's running. We're looking okay. Nothing too scary. Decent temperature split. It's got to stabilize out. I'm going to go ahead and put gauges on the second stage. Again, I'm not diagnosing refrigerant charge or anything right now. I'm just making sure that the unit's running and there's nothing like crazy jumping out at me, and it doesn't look like it right now. We certainly don't have the performance that I want as of yet, but we need to let the system stabilize. I'm going to put the gauges on the second stage and see what happens. All right, I just opened the panel, so that's why my head pressure is so high, but nothing too crazy on the second stage. I will say that when I had it on the first stage, I didn't have it on a fixed orifice metering device, so I changed that over. You notice my superheat on the second stage is a lot lower. I'm a little concerned about the high superheat on the first stage, but again, like I said, I just wanted the system to stabilize out. I'm gonna let it run while I go get a capacitor, and then we'll come back and check it out after that. All right, I am back, and the system has been running for a while. This is still the second stage that we're looking at right now. You notice our head pressure is a little bit on the high side. It's not horrendous, but, and if you use the Measure Quick Diagnostics, it says dirty condenser potentially, or non-condensables. I highly doubt it's non-condensables, but let's look at our numbers here real quick. Unit's still running good. Yeah, let's I have a feeling that there's I was kind of wondering about this condenser because this has a split row condenser. So I was honestly already gonna probably pull this thing apart. They canceled preventative maintenance at this location, so these things can be very deceptive. Even though it doesn't look bad, they can be very dirty on the inside on the split row. So I think I'm gonna go ahead and pull this guy apart and have a look at it. I gotta power it down to change the capacitor anyway, so sometimes they have these, sometimes they don't. This one right here has a panel, and let me see if I can get you guys a view of that. Look at that condenser. Plugged, man. Look at that. And there's a third condenser. You see there's 3 rows on this one. So we have some dirty situation going on here, so we're gonna have to do a proper cleaning on this guy. If you use your big boy muscles, you can just flip this guy over. I grabbed one of these and just wrenched on it. Lifted it up and over nice and slowly. I unhooked the electrical for the condenser fan motors, and then I'll be able to get in there and pull that condenser apart now. All right, we got the coil cleaner on there. It's about time to rinse it off. It's all inside. It's going through there, through there. We got it from all angles. We're gonna give it a good rinse now. All right, I did one last rinse with coil cleaner. It's coming out the other side nice and good. We're gonna give it a good rinse and get all this stuff off, and then we should be good. Well, that didn't quite go as planned, but there's no damage. Good thing, that's why that top rail's there. I wouldn't have done this by myself if I didn't have that top rail. But there's no damage in there, it didn't hit nothing or anything. So, all right, looks good. We're just putting it back together now. All right, we're looking at the second stage right now. The unit has been running for about 15 minutes. I hosed off the roof while I just let it run. Everything is looking good so far. Let's go through it here. A decent split. Condenser might still be a little bit wet, but I don't think so. So we're looking pretty darn good. The performance, the delivered performance, well, I guess it's not bad. I'd like it to be a little bit higher though. It's on the tail end being on the low side. But remember, the first stage, we haven't checked that yet. So we may be low on gas on the first stage, but this is the second stage. So it's pretty much doing everything. And we got an all clear up in the right-hand corner from Measure Quick. We got the little checkered flag. So airflow's half-ass decent. All right, we're gonna go ahead and probe up on the first stage now and see what that's doing. All right, so the first stage, here's what we're looking at. Superheat's high. This is a fixed orifice metering device. Suction pressure's a little bit low, head pressure's a little bit low. The split's going to be the same because it's using the same sensors. So I'm pretty confident that we're a little low on charge on the first stage. Also, just, you know, indicators, we've got the same return air temperature. And the second stage is sweating back to the compressor. The first stage is not. Let's see what Measure Quick has to say. Measure Quick even says that it looks like it might be low on refrigerant. That's my thought too. I'm gonna go ahead and add a little refrigerant to the system and see how it takes it and see what happens. See if we can get that superheat down a little bit. But before I add refrigerant, I am gonna power down the unit and make sure that the belt is nice and tight. And just do a visual on the evaporator coil just to make sure. So I use, when I'm charging with my smart probes, I've shown this before, I just use a hose with a low loss fitting on one end and a ball valve on this end. And I've got that fitting right there that I can charge right into on the low side. So, and it works really nice. I weighed this drum before I brought it up. It was a brand new drum, so it weighed 36 pounds exactly. So that's good, because now when I go down, I just weigh it and then I know how much I use. So just adding a little bit of gas. You got to be careful. Sometimes sometimes you got to make sure that you get good temperature readings on those bigger pipes. It's almost at the border of where that pipe is too big for that clamp, so you got to be careful about that. Okay, I'm not going to get too much more crazy than that. I don't know. I don't even think I added like 3 pounds, maybe 2 pounds or something. We'll see when I get downstairs. But we've got a green checkered flag from Measure Quick, but basically I got closer on my superheat. My delivered capacity is still low, and my airflow kind of dropped down. But remember that Measure Quick's airflow is just an estimate. But my delivered capacity got a little bit better, but it's still a little bit low. It's on the lower side. I'm kind of curious too about the return air grill, so I am going to go take a look downstairs and have a look at that return air grill. As far as the blower belt, it was nice and tight. The evaporator could use a cleaning, but that's a big process. That's not an easy thing because this is a downshot. I can't do that today, but it's not plugged, so I definitely would like to clean it though, but that one's something I'm gonna have to get approved by the customer. So this is probably where we're gonna leave this one. We've got it much better than it was when we arrived. So the unit took about 7 pounds of gas. So, but yeah, I like to weigh it before I go up on the roof if I can, so that way that's one extra thing I don't have to take on the roof is the scale. All right, I cleaned up the roof better than it was when I got here. Definitely cleaned off all my coil mess. You know, there's a little residual, but put all the screws back in the units, washed all the stuff down the floor drains. Gonna tighten up some handles on those doors, rolled up the hose. I wanted to talk about this refrigerant charge. So this unit was low on charge. Certainly refrigerant doesn't disappear, so that means that there is a leak somewhere. I have to run that by the customer. We're in the middle of this COVID thing and they need the unit operational, but things like cleaning the evaporator coil, because that's going to take me a while. You know, cleaning the condenser, I could do that because I fell within the not to exceed value, even adding refrigerant, but I'm pushing my not to exceed value on this call. So everything else I gotta kind of run by the customer. So we'll basically just tell them, hey, this unit was low on charge, we got you operational, we cleaned the condenser, and then we can see if they want us to come back and diagnose. I have a feeling they're not going to want to do that again because we're in the middle of this COVID thing and they just want to get things operational and try to save as much money as possible, even if it costs them a couple bucks down the line. You know, most of them are okay with that right now because they just want to offset their expenses for the most part. So yep, that's pretty much it. We're going to wrap it up.
I certainly dodged a bullet when I dropped that condenser lid, huh? So that Trane unit has this metal strip that covers the condenser as like a protective thing. In the past, they didn't used to have that, and you would have rub outs on the top from the condenser shroud cover, whatever, just leaning on the condenser. But I guess I'm thankful they put that on there. I probably, like I had said in the video, probably wouldn't have done that by myself had I not had that metal cover there, because I was able to get the condenser up, but boy, man, did I dodge some bullets dropping that thing on there. So I wanted to address something. Measure Quick. I really do like Measure Quick. It does a great job, but any software's out there. You cannot just rely on a software. You have to use your own brain to kind of diagnose things too. Now, I will say that 95 to 99% of the time, Measure Quick is accurate in its diagnosis, especially when we're dealing with air conditioning systems. So I give it a lot of props because it does a really good job. But you have to know how to input the information correctly, right? There's some certain questions that Measure Quick asks you, such as the design temperature differential, the condensing temp over ambient, you know, things like that. So you have to understand how the system was designed, okay? Just keep that in mind. You can't just, you know, expect a piece of software to do all your work for you. I really do like software. I like what it can do for you, but you have to know when it's inaccurate, when you don't have a sensor in the right place, you know, all kinds of things like that. Another thing to think about too, when you're working on package units, you're not really supposed to put the psychrometers or, you know, the supply and return air probes within eye shot of the evaporator or the heat exchanger. Okay, so in this situation, I'm working on a package unit, and I had my return and supply air probes just in the top of the unit. Ideally, you want to take those downstream in the ductwork where they can get an accurate temperature, where they don't have any residual cooling coming off the coil or radiant heat coming off the heat exchanger in the heat mode, you know, that kind of stuff. So, you know, you have to know how to interpolate this data. And in all reality, it's not practical sometimes to go put your return air probes all the way down in the ductwork, because this is a restaurant and I can't really get up to the return air stream. Okay, so sometimes you have to learn how to like work with things. So things like the delivered performance and stuff, that could be skewed a little bit. Okay, I was a little bit more concerned about my superheat, you know, looking at my subcooling being high, you know, that kind of stuff. Okay, just be cautious when you're using the software. It's a tool to make diagnosing easier. It's not meant to diagnose for you. That's my opinion, at least. And that's with any software out there. Measure Quick, the Fieldpiece app, the iManifold app, any of those. Okay, that's just my 2 cents on that. All right. No affiliation with any of those guys, but they all make great products and great software. You just have to know when it's giving you inaccurate data or incorrect data, maybe just simply because you didn't put the temperature clamps on right or something like that. Okay. So this one wasn't too difficult. We had a dirty condenser. We had a refrigerant shortage. We corrected those problems. I brought to the customer's attention, much just like I had thought, I brought to their attention that the unit has a refrigerant leak and they really didn't want to go any further with it at this time. They just want to leave it be. And the same thing, I told them, hey, I'd really like to get in there and scrub down that evaporator. But again, they declined that one too, because the unit is doing what it can right now, and we're in the middle of COVID, and I certainly don't blame them. They just want to get things operational and try to limp through. So right now it's April 28th. I think this video was shot earlier this week, maybe 3-4 days ago, or something like that. And restaurants at this time in California still are not allowed to have people in their dining room. They're only allowed to serve to-go food or takeout food. They are hurting very bad, just like everywhere else in the country. So times are tight, you know, so we just got to do what we got to do to keep the customers up and running and keep them happy in hopes that they call us back. You know, got to make them happy. All right, I really appreciate you guys taking the time to watch this video. Leave me some feedback down in the comments. Send me an email. Keep in mind, I do live streams Monday evening, 5 p.m. Pacific time. And I don't really push this stuff out there. I like to throw it in at the end of the video for the people that watch all the way through. I now have affiliate links in the bottom of this video that get me a small commission with TrueTech Tools. Click the links. It helps me out. Even if you click the links and you buy something else, it still helps me out. So there's also an offer code that you can use to get 8% off your TrueTech Tools order the offer code is Big Picture, one word. Put that in there. You'll get 8% off, and you'll help to support my channel. Okay? Thanks again, guys, and we will catch you guys on the next one.